All right, we got the Kelly controller, the KDZ 124 400 amp controller, and I have it connected to the high voltage batteries from the smart car. And instead of running a motor, I have this rotary converter hooked up to it. It's a Carter rotary converter. That's its input voltage right there, and its output voltage. So even though these batteries are like 80, 90 volts DC, the controller lets it, you can control the throttle of it. Take this, connect it to here, and then you start to turn the throttle. Because there's such high DC voltage, it's kind of, but it's running this right here. But it's at too high of a voltage though. I need to set the settings for the controller in my laptop so it doesn't use as much voltage or throttle. But it's a way to control your AC power supply from a DC source, where if you put on a load and the RPMs of the converter go down, you can then increase throttle on the controller over here, and that'll allow you to pick up speed when there's drag happening on the converter. So it's basically an off-grid system where you can control the input voltage and output voltage. If there's a heavy load, you can increase it. If you're going to disconnect the heavy load, you can decrease it. That way you don't get too high of an RPM, or you get too little of RPM and you get the converter to stall. So this is just a test bench that I'm using right here. So this is not the setup that I'm actually going to use. This is just for testing and getting the settings where I want it for the controller. But this is the basic idea for an off-grid control system for DC to AC current, where you control your DC flow to your converter, and if you need to connect a high load, you can increase voltage, or if you're going to disconnect the load, then you want to decrease voltage. And that way you don't have any imbalance effects on your system. Pretty straightforward.